let's talk about the blind test between the two options or the two subjects. So in here I have two subjects. Subject A, which is to generate random data frame or table with random unif function. So unif to generate a uniform distribution with two dimensions x and y, and then I will color code it blue. Okay, and then the subject B, which is doing the same thing, but I will color it, code it red, and then I use this function unif h5, which is the random uniform distribution by the hashing method md5. Okay, so the subject of the test is just to see, can you tell apart two of them? Okay, so if randomly so the subject the purpose of the test is to, can you tell which function is which from the view from the test. Okay, so if you cannot tell the function which one is which, then basically they are the same. Okay, so this subject that B is to generate a data frame from this function, and then this A is from the standard function, and then I won't tell you which one is which in the test. So this is the test. So if I will randomize the test also. So test either A or B. If the test if the random number is below 0.5, which is a half, and then I will generate subject A. If otherwise, I will generate the subject B. Actually, I don't see any important for subject name because I color code them already, so it doesn't matter. It's okay. And then I will generate, I will visualize those points in with the ggplot function, and then you can see things like this. Okay, so there you go. So you have the picture here, and then can you tell which chart is generated by which method? If you cannot tell, then basically they are the same. So to be honest, if you tell me, I also cannot tell any of them. They look the same to me. This one I generate like only 500 for each chart, but then if you go to like 1000 or 5000, it will be more crazy because you cannot tell which one is which. Okay, now I will tell you now. I will do the same thing. I just randomize the test with the color. So I will draw this is the same chart but with the color, and then the color will be here. If the subject is B, then the color is red. If subject A, color is blue, and then I will show you. There you go. So now you know the answers already, and then even when you know the answers already, you cannot tell which to be honest, they are the same to me. Actually, to me it's like you look at the picture of the galaxies in the sky, and then they are the same to me as well. So you can have some similarity. For example, okay, so it will be very okay. So there are two points here. This one also have 2 points. There this one has 2 points also, but then they are not. Actually, you tried. To me, it's like in the random pattern, you just like very desperate to you try like uh, your best in order to make the pattern out of it, but it doesn't have any pattern at all. So what does it mean in overall? in overall that if you have two subject like this subject A and subject B to generate random points x and y, and then you visualize the x and y in a chart, and then you shuffle them randomly around the over the 10 test. Okay, hold on. I need to visualize the test number in here, otherwise it will be difficult to plus plot name GG title, sorry, title name. Okay, so you have the test name already. So for you take randomly 15 tests in total. Test 1, test 2, 3, and then all the way to 15. And then in each location, in each test, you just take randomly subject A and subject B. So A will be in blue, and then A will be in blue, and then B will be in red. And then you generate randomly the point by method A and method B, and then you ask the audience or ask the random people, can you tell me which one is A, which one is B? And to be honest, this one I cannot tell. Okay, you can there's a parameter here which is a seed number. You can change the number. So let me change this one to 1 2 3 4. So it will randomize the test uh, in different ways as well. So in here maybe you have 1 2 3 and then you have more B than A, or more blue, more red than blue. So if you change this one into another number, for example 3 4, and then maybe you have more blue. Okay, so you have two blues in front and here. So basically the subject to be tested will be selected randomly, A or B, you don't know. But then the thing is, you cannot tell, even when you select randomly the test like this, you cannot tell which one is which, meaning that if you use a function runif or runit h5, they will be the same in all the simulation or all the visualization. Okay, so that's all about the A/B thing. I will take the same function, the same method with the to differentiate the two function as well, which is subject A will use the unknown function to generate the Gaussian sample, and the second one will be unknown H5, which is the same thing, but it generates the Gaussian distribution. I will remove this one. I think I don't need this one anymore. Unknown distribution from the MD5 method. Okay, and then the structure of the test is the same. I just generate the test A, B, and then 10 of them, 15 of them, and then I need to copy this name over here, and then I just take A or B randomly, and then you tell me which one is which one's A or which one's B. Okay, so let us do the same test again. Okay, so this one is for very obvious already. So let us change the test into the not obvious one, which is to hide the color, and then I change the seeding number as well. So 1 2 3 4, and now you can tell me which one is which one is method A and which one is method B. Okay, I try to find the similarity myself as well. Okay, looks like I try to see the anchor point here. So look like this one and this one, they are the same, right? But then from the two here, but then the rest they will be different. Someone with the two here, no, cannot. Okay, so basically they are very random. They are like galaxies in sky to me. And then now I will do the same trick, which is to draw the color in the for each test subject. And now you can tell. Okay, so now these guys are from method from subject B, which is red, and then those the rest will be blue. Okay, so now I see actually by randomization I see there are a lot of blue guys and not a lot of red guys. So I basically I need to make change the seeding number in order to see if we have the balanced test or not. Okay, so now the other way around. So I think more red guys than the blue guys. Okay, so basically it doesn't matter anyways, if as long as you cannot tell the difference between the test, and then they will be the same. Okay, by the way, let me change this one to 1000 and then see how they're different. So and n equal 1000 here just mean that we had draw more sample for each test in here anyway. So there you go. So you see they looks very like for each of them they look very dense, a lot of points, but then mm, they actually I can show you the point here. Test. Okay. So this is a name, and then the next one is the count, and then I will change this one to name, and then number row of the GDF, which is the general database, general data frame, and then there you go. So each of the tests has 1000 points. If you change this one to like maybe 5000, they will update the numbers all the way, but then the structure of the test will be the same. There you go. So you see that a lot of points now around here, and then for each chart here or each test you have 5000 points. Okay, but then at the end of the day you cannot tell which one is which, even I show you the colors here already. You know that there are the one from method B and one from method A, but you cannot tell which one is which. You have answers already, but you cannot tell because they are just random. There's no like information gains or clue or visual clues in order for you to differentiate the two. Okay, so that's it, guys. Just to show you how to perform randomization test or blind test using this R script language.